So here's the start of our expression for the add to bit array. I'll do a save. We can call it flat design. We can put expression notes here. These are just our private internal notes. Sometimes I like to just whack the design or the algorithm that I'm using in here for future reference. Speaking of the algorithm, that's listed here. So it's just 5 suppliers and it's a flat design, very little processing. So the expression itself should be quite quick. So if we go back to the vendor principal, the first thing we want to do is join all these committees, because the term committee types are going to be the committee types of the DOFs of our suppliers. So basically the terms of our committees speak the language of our suppliers. So I'm just going to click self in all these committees, which is essentially me automating the vendor to join each of these committees. You can see as I do that, we have access to the terms of every one of these committees because the vendor is now part of the committee itself. So we have access now to the chair construction site that we have requested from our client, which is where we're going to park our own code. We've got access to the location of the bit index when the outcome is int64, and we have access to the location of the bit array itself when the outcome is 64-bit multiple, and we have chaired the committees for when the bit has been added and when the index is out of bounds. These construction sites are reps because as far as the client's concerned, they are given back access to smaller construction sites or flow committees in which they can chain further work for when the bit was successfully added and when the index is out of bounds. So we're responsible for providing the source of that construction site. So that's why it's a rep here. It's basically the client saying, I need the construction site for when the bit's added, and I need a construction site for when the index is out of bounds. And you, us, our vendor, are responsible for providing that. So you'll see where that comes from soon. So now that we've joined each one of those committees, we can go ahead now and start contracting some suppliers. And again, you don't have to join the committees first, you can just plonk down all your suppliers, it's all up to you. So we need that dereference. Now you'll see I've contracted a dereference 64 bits. And the reason for that is we are going to be dereferencing the location, so obtaining the value of the bit index, which in this case is int64, but we're going to be automating for the case where the integer is 64 bits, which means we need a dereference 64 bits. So that's why I contracted that supplier. So I'll just say deref location of bit index. You can put more details here if you need. I'm just going to leave the maximum payable set as the default, which is the amount that Dow will be charging for this service. I also need that comparison. And again, we need to get that 64-bit integer comparison, and we're doing checking whether a number is greater than a constant. In this case, checking whether the index is out of bounds. So we want to check whether the bit index is greater than the length of the bit array. If it is, then it's out of bounds. If it isn't, it's in bounds, and then we can go ahead and set the bit at the relevant index. So you can see we're racking up DOFs here for each of the suppliers. I'm not going to start organizing them yet. I'm going to lay down my other suppliers. So I need, and if we just want to refer back, contracted as dereference, the comparison. The comparison will give me construction sites for the true and false cases. In the true case, I don't want to do anything because it's out of bounds, and that's where I'm going to chain that construction site rep term. In the false case, I'm going to contract that division, addition, and the set bit. So if we jump back here, we can contract those 3 suppliers. We want a compute, and again we're doing 64-bit. First the division with the constant denominator. Dow is the byte layer guru. He's going to be my supplier for all of these contracts. The number of bytes. And the addition. We want the default case, which is where they're both variables. So we'll do the target location that the set bit requires will be equal to the location of the bit array plus number of bytes that we calculated above. And then the last supplier we want to contract, of course, is the set bit. And again, we want the default case, not the constant, because the index is a variable. Excellent. All right. So we have quite a few DOFs here that we need to organize into the appropriate committees. You'll also notice that the division supplier requires the denominator as a constant, so that's going to be a crossover in our processing, which we'll get to in a second. So now I'm going to go ahead and first organize my construction sites. So you'll see I've got quite a few here to play with. This construction site here is the main construction site in which we're going to organize the start of our code. So that's that add dof here. That is the construction site term of the add dof for the outcome inline. And you'll notice now it's no longer red because it's been organized. So I'm just going to go ahead and minimize that committee. Now we can start to add a few reps. So the first thing we want to do is the dereference. Now chaining here is very important because this is the order in which it's executed as per that inline outcome. So the order in which we wanted to execute things, we wanted to do the dereference, then the comparison. In the true case, we'll chain the index out of bounds construction site rep. In the false case, we'll do further work, the division, the addition, the set bit, and then chain the bit added construction site rep. So after the dereference, we want to do the comparison. I'll delete those two because now we're going to branch off. The comparison, if we jump over here, you'll see gives us a true and false construction sites as chairs. So that comparison vendor or supplier is providing us back smaller construction sites that are part of this main one here, in which we can organize work to occur when the comparison is true and when the comparison is false. So in the true case, that's where our bit index, you'll see it's organized there. The true case is where our bit index is out of bounds. So we want to trigger this flow. So you'll see up here, the out of bounds, we're responsible for providing that construction site. Well, here it is. So I'm going to organize that term, index out of bounds. You'll see it's now organized. So I'm going to minimize that committee as well. And this one's all done, I'll minimize that. Now the other construction site that the comparison provides us is the false, so I'm going to organize that now. This is where we want to do the rest of the work. So we'll first do the division, then the addition, and then the set bit, and then we need to provide access to this construction site saying yes, the bit's been added, after we've organized the work to set that bit. So that construction site rep for bit added that we're responsible for organizing will go here. Done. So that's now organized as well. So the execution side of things has now been all organized in these construction site committees. What I now want to do is organize the variables, the information. The location of that bit index is what we want to dereference in order to obtain the value. So I'm going to create a new committee for that bit index location. And I'm going to organize this requested location with that chair. See, now it's been organized, and if we hover over it, we can see where, if you ever want to check. So I'm going to create a new committee where the chair is the value of that dereft location. Now the comparison needs the bit index as the first operand, and the divide also needs that index for the numerator. So you'll see now that's also organized, and so is the first operand in the same committee. So we've got all those guys in touch. They're all talking about the value of that bit index. So we have the result and remainder from that division as new committees that we can create. The result is the number of bytes, so we want to add that to the location of the bit array. So that will be one of the operands for our addition, and I'm going to create a new committee. You'll see up here, I might just minimize that. You'll see that the last thing we've got left to tie off with regards to terms is the location of the bit array, which is what we need here. So I'll create a new committee for that. If I pop back up here, you'll see it's no longer red and organized. Come down here and select that as the second operand. So now we're making sure that the result, number of bytes, is being added to the location of the bit array. Minimize those. The result of that addition is the target location. So you'll see the set bit requires the target location and requires the actual bit index, which we both have. The remainder is the bit index from the start of that target location with regards to bits, and the target location is what we just calculated. So they are all done now. I'll minimize them, and those committees are tied off. So as far as we're concerned, the communications is all handled. So we do have to satisfy the processing though. So if I jump over here, we have access to the event when the contract is accepted. We have access to an event when that add flow committee has an outcome of inline. We have access to an event when that bit index committee of type integer has an outcome of int64. We also have access to the maximum and minimum values of that integer. So if we jump back here and look at that bit index, you can see those are the specs, the maximum and minimum value. We have access to those as we've joined this committee as rep. So those are source nouns. So we are responsible for triggering when we want our stance in that flow committee to be inline, and when we want our stance in that integer committee to be int64, and when we want our stance in that bit array committee to be 64-bit multiple. Now you'll notice in these DOF committees here that we joined as rep, there is only one outcome, the catch-all outcome, that we're going to automate for in this case. So I'm just going to trigger my stance of the catch-all outcome to occur upon contract accepted. So I'm basically saying I always want to say my stance is the catch-all. There's those three. And when that add flow DOF, this one here, this committee here is inline, I want to make sure that I return flow construction sites that are also of the outcome inline. Again, it's just a preference. We could organize these two stance triggers up in contract accepted. I'm just going to put them here. So those are done so far. So we have access to the bit index in when int64. We definitely only want to trigger the dereference, the comparison, the division, and the addition, all only when the outcome of that bit index committee, this one here, is int64, because all our suppliers were 64-bit specific. So it's very important we organize them to occur only when it's int64. We have access to the maximum and minimum values, which we're not going to use for this flat design. We have access to the bit array 64-bit multiple event. So when the outcome of that bit array committee is 64-bit multiple, do we want to trigger anything specific? I'm going to trigger the set bit in that case there as well. We're going to be using that bit array length in a moment, and I'm just going to minimize these inline events because these are basically saying when the outcome of the bit added and index out of bound flow committees are inline, do you want to trigger anything? Well, I actually know they're going to be inline because our vendor is the chair. So I'm just going to minimize those. So over here you can see a lot of these nouns have been organized, so I'm just going to minimize these committees. And these are syncs that require source values. Minimize those as well. So this is the second operand associated with the comparison. So if we jump back here, that's this one here. So our comparison, we're comparing a variable with a constant, and that constant is the bit array length. So that's known at design time, which is what this window is all about. So I'm going to organize that second operand sync underneath this length source value to make sure it gets the correct value. That's done. And the last thing we've got to provide is the denominator for the division. So if we jump back here, you can see it's also requesting that info at design time. So we've got to provide it at design time. Design time of the overall build, runtime of our vendor. So I'm going to define the value 8. And that is a bit array specific, so I'll trigger it there. So that's just triggering when that noun value is created. I could just whack that up in contract accepted. We have a little bit of freedom here. And so we have access to the byte that we just defined, the 8, and the length. In this case, we're not going to do anything with the length. I'll minimize that and organize the denominator there. And that's it. We are now all done. This is just my OCD telling me to make everything nice and neat before I build. Minimized, minimized. It's also a really good quick way to see if there's any outstanding committees, terms, DOFs, nouns to be organized. So down here we've got the maximum payable per contract. So when our vendor gets a contract, we're going to be forking out 1400 Satoshi in total to these 5 suppliers, which means we want to at least charge 1400 for our own vendor contract price. Over here we've got the build cost of this actual vendor. So the vendor principals just captured our requirements, but this vendor doesn't exist yet. It's got to be built. It's got to be built so that it has this automation, which causes these contracts and these committees to be organized. I'm just going to save the expression. Now I'm going to build this vendor.
Building. Construction
complete. Jump back to our portfolio now to check on our build. And you can see our vendor build has already got a status of built. It's been built. So that's our expression. That's the corresponding build. We can now create an actual program by contracting our new vendor.